Okay, hello everyone. So today I'm going to continue into this part, your transformer. Alright, so I'm just going to do a what we call a basic revision on your transformer. Alright, since you have already learned this in class, so I think it would be better if I just focus on the important characteristics of a transformer, to help you guys for your revision in your exam. Alright, okay, so let's go through a few basic things about a transformer. First, of course, you need to know the function of a transformer. Okay, so by now, if you still don't know the function of a transformer, then you need to know. All right, it's basically to change or convert your voltage. All right, your basic function of a transformer is to change the voltage, or sometimes we say we can change the potential difference. Instead of using the word voltage, we use potential difference, but only for an alternating current. So this is the first important thing of a transformer. They can only work with alternating current. They cannot work with a direct current. If you use a direct current, the transformer will not function. Alright, so this is basically a diagram just to show you guys. Okay, just in case maybe in the exam they show you something like this. Okay, this is the transformer that you will see at a power station. Okay, this big thing, this whole thing is a transformer. Alright, and this is the design of a transformer nowadays. Alright, so you need to roughly know what they call the shapes and designs of a transformer. Okay, so structure of a transformer, this one you must know. Labeling. Alright, so you need to know all the components of a transformer. Okay, first thing, the metal in the middle here is what we call the laminated soft iron core. Alright, so why we use laminated? Okay, this one I will explain later. Okay, you need to know why we are using laminated. What is the meaning of laminated? Okay, so never mind, we learn the structure first. Laminated soft iron core. Okay, and then you need to know where is your input, where is your output. Alright, because you say transformer is used to change your voltage, right? So you need to know your input and your output. Now, a lot of very cute students, they will tell me, oh teacher, the input is on the left, the output is on the right. If you memorize like this, then oh god, it's gg.com. Okay, to know where is your input and your output, you need to know, you need to look at where is the power source. Okay, where is the input? Okay, you don't memorize left and right. The design of a transformer, right, is not necessarily left and right. I can put it up and down also. Okay, so how to identify your primary and your secondary, or your input output, is based on where is the position of your power source. Now, if you see this symbol here, right, this is a symbol for your alternating current, meaning I know that this is my input, this is my output. Okay, so it depends on where is the position. If you cannot identify input, right, then you look output. Output is normally where they will put, let's say for example, your light bulb maybe, or your electrical appliance. Okay, oh my god, my laptop a bit cacat lah. Alright, okay, output. Okay, something like this. Okay, input. Okay, sometimes they don't use the symbol. Alright, so maybe they are going to attach it to a maybe power source. So a power source, this is a kindergarten drawing power source. Maybe draw something like this lah. Okay, so you know that this is your input, this is your output. Alright, so if this one is input, meaning this is your, this one will be your primary. Okay, primary coil, and this will be your secondary coil. Alright, and here will be your input voltage or primary voltage, and this will be your output voltage. Okay, so this is a basic component of a transformer, the part of a transformer. You need to know the labeling. Alright, and then the coils. Okay, so drawing a symbol, of course, when you draw the symbol of transformer, you need to make sure the number of coils is matched with your type of transformer. Alright, so this is important. Operating principle. Now, how does your transformer function? Okay, or the physics concept they are using here is the electromagnetic induction. Okay, the operating principle of how a transformer works, all right, is using electromagnetic induction. Okay, meaning we are using induced current. All right, so later I'm just going to show you, I'm just going to explain very briefly how they work. Okay, so this is the first part of your transformer. All right, and then you learn about two types of transformer. Okay, step up and step down. All right, up is to increase your voltage. All right, down is to decrease your voltage. So it's actually very logical. If you want to increase your voltage, right, meaning that your primary coil must be less, your secondary coil must be more. All right, so your input is less coil, your output is more coil, then only you can increase your voltage. All right, if you step down, then it's the other way around. Okay, so when you draw the symbol for a step up and step down transformer, you need to make sure that you draw it accordingly lah. If it's step up, meaning your primary here, the number of coil is less. Okay, the secondary one, the number of coil is more. Right? If it's step down, then it's the other way round. Okay, all right. Now for a transformer, okay, let's say lah, I'm using this one lah. Let me use back this diagram. Don't. I use this diagram. Okay, now initially, if let's say this is my input lah, why I rub off Okay, so if based on this design, right, if I already tell you that this is the input, this is the output, okay, meaning that this is more coil to less coil, this is step down, right, decrease voltage. Okay, can this be changed into a step up transformer? All right, you need to understand that a transformer, I can make it into up and down depending on where I put my input and output. Meaning one transformer, I can make it into up, I can also make it into down. I don't need to use two different transformers actually. Alright, I only need one transformer to change up, to make it into step up or step down. So how to modify? Alright, okay, let me just show you an example. Okay, how do I modify to make it into a step up? Let's say step up. Right, so this one initially is a step down. So how can I change it to make it into a step up? So the first thing that I can do is I switch the position. Oh, forgive my writing of your input and output, meaning you change the position of the two things. So meaning this one you tukar. So here you put your input, your power source, and then you put maybe your light bulb or your phone or whatever here lah. Okay, so if I put it like this, right, meaning that now this is my primary because this is input. So this is primary coil, this one is secondary coil. So less to more, so it will change into step up. Okay, so this is the first thing that I can do to change it into a step up. Now, a second way to modify is if you look at the number of coils here, right? Okay, what I can do is I increase the number of coil or number of turns of coil, number of turns of coil in the secondary coil. Alright, okay, because I draw back the original one. Okay, so this is a step down. If I want to change into a step up, first I change the position of these two, the input and the output I switch. Alright, second, alright, since this is primary, right, this is primary, this is secondary, right. Okay, the second method to modify the transformer is I just increase the number of turns in the secondary coil, meaning I make it more than the primary, or I decrease. So it's either you increase the secondary coil or you decrease the number of turns in the primary. Okay, so that is how you can actually modify your transformer. Alright, this is more like the K-Bar question They will ask you how to modify so that it becomes a step up. Okay, so just remember the two things. Just remember the basic concept of a transformer. You just switch the position or you change the number of coils either in the primary or in the secondary. Alright, the same thing goes for a step up transformer. Right, if they want it to change into a step down, it's also exactly the same method. All right. Okay, so hopefully this one you all can understand how we modify a transformer. Okay. Why we use laminated soft iron core? Okay, there's a reason why a transformer is using laminated. Laminated meaning that your transformer is not a whole block of metal. It's actually layers of metal. If you see here, individual lamination. So basically, it's like different layers, they stick together. All right, so why they do this instead of just using one whole block like that, straight away pop. Okay, there's a reason why we do this. Okay, now before I explain about the eddy current here, you need to roughly know the operating principle of a transformer, meaning how a transformer actually works, right? I just explain as briefly as possible just to give you a rough idea of how it works. Okay, a transformer functions, we know that they change the voltage, right? But how do they change the voltage is like this. Okay, if you look at my red wire here, right, this is your coil. This is your primary coil. This is your secondary coil. All right. Now, for a transformer, we only want the current to move in the coil. Okay, meaning I want my current in the coil. I only want the current to move in the coil. I don't want the current to move in the metal. All right. So basically, your function of your laminated soft iron core or this one, the purpose of this thing is actually to become a temporary magnet. Okay. All right, because we say we are using the concept of induced current. So if induced current, I need two things. One, I need a magnet. One, I need a conductor. All right. So the function of the metal block here is not to allow current to move. No, your current is only moving in the coil here. So looking at the design, right, people will question, if you say the current is only moving in the coil, then how here suddenly got current? Because the current, the coil, the wires are not connected, right? It's two different places, right? So how does a current here cause the current to move here? Okay, now as the current moves along the wire around here, right? As you call it around the metal, and then this one you have a metal block and it behaves as a temporary magnet. What happens is like this. When current starts to move here, all right, you are going to cause a change in the magnetic flux, meaning like this. Remember in the first part in 3.1 we learned, right? When a current moves through a conductor, they are going to produce a magnetic field. Okay, if you remember your this one, all right, go up and then you use your right hand rule, right? Right hand grip rule, and then you will see that the magnetic field is going this way, clockwise, anti-clockwise like that. Okay, this is what you learned in 3.1, right? Okay, so in this case, same concept applies. When a current moves through the conductor, which is the wire here, okay, they are going to produce a magnetic field or there will be a change in the magnetic flux here. All right, so when there is a change in the magnetic flux, okay, meaning to explain it in a more layman term, right, meaning that your magnetic flux here or your magnetic field starts to move on the left side. Okay, I just separate into two parts first. All right, so here input current moves. All right, so as they move, you produce magnetic field, and then you will cause a change in the magnetic field in the soft iron core here. Right, meaning your magnetic field here will start to move. Okay, so when here starts to move, right, this will affect the magnetic flux on the right side. So a simple analogy will be this, everyone can relate to this. In the class, when the teacher is teaching halfway, suddenly your friend starts to yawn. If you see one starts to yawn, everybody starts to yawn. It's a very contagious one, right? So same concept applies here. When here starts to move, the magnetic flux here also starts to move. Okay, I'm using as simple term as possible. I don't go into too technical later. You don't understand what is going on. All right. So again, repeat again. Current moves in the wire. All right, cause a change in the magnetic flux on the left side. So when here starts to rotate, here also starts to rotate. The magnetic field also starts to rotate. So when you have a magnetic field moving and then it's cutting the conductor, right? And then this will produce the induced current here in the wire. Okay, so you are going to produce the induced current. All right, so your That's why we say that a transformer functions through a electromagnetic induction. Okay, so that's it. All right, how a transformer works. Okay, is through electromagnetic induction. All right, so we only want the current to move in the wire. Okay, current moves here in the wire. Here, magnetic flux starts to rotate. So when here starts to rotate, here also starts to rotate. So here magnetic flux rotate and then cutting conductor, then you are going to produce an induced current. All right. So here is where you produce your induced current or your induced voltage lah. All right. Okay, electromagnetic induction. Okay, which is this part. Okay, so what is eddy current? It's like this. Since your current is moving in the coil, right, and since this is a metal, meaning that, let me move this first, it's very difficult for us to make sure or to ensure that the current won't flow into the metal, meaning a small amount of current, right, that flows in the wire will suddenly flow in the metal as well. Since it is a conductor, meaning it can conduct electricity, right, meaning the current can flow in. Now, the problem when the current flows into the metal is like this. When the current goes into the metal, right, okay, current has no sense of direction. Okay, they don't know left, right, up, down. They just hantam only, just muscle and just boosting only. Alright, so when the current goes into the metal, what happens is that the current don't know that they need to move to the other side one. So what will happen when a current enters the metal is, since they can just simply move, right? So in the end, the current will just go in a circular shape. They will just go muscle and then they will just rotate inside only. So they are not going to move to the other side. The current is just going to like circle around inside the metal. No sense of direction, so they just go round and round. Alright. So this is what we call eddy current. Eddy. Okay, eddy current meaning that the current is moving in a circular shape. Now the problem with eddy current is like this. If your current is moving in a circular shape, right, meaning that your current is not moving to the other side, meaning it's like concentrated. Okay, so your current is constantly moving here, it keeps on moving at the same spot. Move, 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 move. What happens is that you are going to heat up the metal here. Alright, so when there is eddy current, the metal will heat up, meaning that there will be energy loss. So it is not efficient because your transformer will heat up. So once the transformer heats up, right, meaning there are a lot of energy is being wasted as heat energy. We do not want that in the transformer. Alright, we want to make sure that the energy or the current or the voltage, okay, is transferred to the other side as efficiently as possible, meaning I don't want to have any energy loss. But by using a whole block of metal, some amount of current will flow into the metal and they will start to rotate, thus producing an eddy current. When you have eddy current, the metal will heat up. So there is an energy loss. So if you see here, eddy current. Alright, so why we use laminated is so that we restrict the movement of the current. Okay, how do we restrict? It's based on the concept of your resistance. Alright, if you remember your resistivity formula, okay, your resistivity formula, your resistance, right? This one. Okay, so the concept is like this. When the surface area is smaller, alright, your resistance is higher. Now, without a laminated one whole block like this, right, this surface area is very big. So resistance is low. That's why the current can flow into the soft iron core. But when we do it into laminated, right, thin strips of metal stick together, right, what happens is that you are reducing the surface area. So when you reduce the surface area, the resistance here will be higher. So current, they are very simple. If high resistance, meaning they don't want to go inside there anymore, they won't flow there anymore because of high resistance. So this is how they control or reduce the production of eddy current, right? So instead of using one whole block of metal, we use laminated, so layers. Okay, layers, right? Let me just draw. Okay, so layers, okay, meaning like this. So by doing this, you are actually reducing the effect of eddy current. Since you have higher resistance, the current will not flow into the what they call metal. Okay, so remember the soft iron core here, or the this one, right? The function is only to be a temporary magnet. Okay, is not allowed to current, is not for the current to flow to the other side one. This is a common misconception. Right, when we say that a transformer reduces voltage, you think that the current is moving in the wire and then go to the metal and then come up from the wire again. No. All right. Okay. So hopefully this will help to clarify, all right, the meaning of eddy current and then why we use laminated soft iron core. Okay. Habis cerita. All right. Okay. So the formula here for your transformer. Okay, VP over VS, all right, primary voltage over your secondary voltage. All right, this formula, right, is actually for you to know the relationship between the number of turns and also the what they call voltage. In other words, if let's say, right, if I were to increase the, or let's say if the ratio between the primary and the secondary voltage is like 3 times, meaning that the ratio between your primary voltage and your secondary voltage is also 3 times. So let me just give you a simple example lah. All right. So let's say the primary coil, secondary coil. So let's say the primary coil is 10. I have 10 coils in the primary, and then I have 80 coils in the secondary. All right. So this one will become a step up lah, because this is going up already. Okay. So the ratio here is 1 to 8. So if my voltage in the primary coil is, let's say, 2 volts. Alright, since this is 8 times, right, meaning in my secondary coil, the voltage is also 8 times. So 2 times 8 will be 16 volts. Okay, so that is actually the function of the formula here, to show you the relationship between the number of turns and the voltage. Alright, so conclusion is number of turns increase by how much? Your voltage also increases by the same amount. Alright, okay, that is it. Okay, brief introduction on your transformer. Alright, so the next part I'm going to go into all the calculations using the formula how to calculate, and then I'm going to go into also your ideal transformer and also efficiency and the national grid network. Okay, I will focus on the calculations on that part. Alright, okay, I'll see you in the next video. Bye bye.